closely, it is really very interesting to discuss the intermolecular forces. So already we have seen what are the various intermolecular forces, the dipole-dipole interaction, the dipole-induced dipole interaction, and the induced dipole interaction. So these are all the things we have seen earlier. And it is quite interesting to know that if you take neutral molecules, that is molecules without any dipole moment like methane or inert gases, normally when these molecules come critically closer to each other, suppose you take a methane molecule, the methane molecule as such, it does not have any intermolecular attraction as it is a non-polar compound. But when these molecules are brought closer, what happens? Every molecule has atoms, and these atoms have negatively charged electrons and positively charged nucleus. Therefore, there exists some electrostatic attraction between the molecules because the nucleus which are present in one molecule will have an attraction towards the electrons present in the other molecule. And also the nucleus present in the other molecule will have an attraction towards the electrons present in these molecules. And at the same time, inter-electronic repulsion, internuclear repulsion are also seen. Therefore, the intermolecular interactions are found even in the molecules which are neutral. So that is what we are going to discuss today, the electrical properties of various molecules. So far we have seen the dipole moment or the hydrogen bonding, which originated because of the difference in electronegativities. It is also a type of dipole-dipole interaction, but the hydrogen is involved. And because of that hydrogen, there is an attractive force between the hydrogen and the highly electronegative atom of the other molecules such as fluorine, oxygen, and nitrogen. And I have also explained to you the existence of the various important biological things like the silk thread or wood pieces, and so many natural things which are existing because of the hydrogen bonding between the fibers and all the things, and also the biological importance of hydrogen bonds we have already discussed. Now we are getting into the electrical properties. So the electrical properties of molecules, I'm going to share with you the PowerPoint which I have prepared, and you see now. I think you are able to see now. So importance of a hydrogen bond we have seen. Now, the electrical properties. Dipole moment mu is equal to Z into L. L means the length between the center of the positive charge and the center of the negative charge. See, you should not get confused. When you refer to different books, there are so many books for physical chemistry. I will mention a few for you. You can go through these books. Fundamentally, you can use the Puri and Sharma, which is you are all having. And there is a book called Castellon. And there is another book called Atkins. In every book, different symbols and different notations are used. See, in the book what I have referred, it is mentioned the mu is equal to Z into L. In some books, it is written as Z into D, small d, which means the distance between the center of the positive charge and the negative charge. Therefore, you should fundamentally should have the understanding it is the charge multiplied by the distance of the separation between the center of charges, whether it is L or D and whatever it may be, because that thing will change from book to book. So you should not get confused. So it is written here, the dipole moment mu is equal to Z into L. And the unit for dipole moment is d by. So d by is the unit for dipole moment. So look here, the neutral molecules contain positive and negative centers. But on the neutral molecule, the center of all the positive charges and the center of all the negative charges will fall on the same point. That is why they are found to be electrically neutral, because the center is on the same point. So center of the positive charge is on the same point. The center of the negative charge is on the same point. Therefore, there is no distance of separation between the opposite charges. Therefore, what will happen, even though it may have Z, the charge, the multiplied by the length of a separation between the charges will become 0 because they fall on the same point. Therefore, the dipole moment mu becomes 0 d by. So, symmetry also plays an important role in this. Today, the 5th hour, I will be discussing the same in the group theoretical view, how symmetry plays an important role in determining the dipole moment of a molecule. Why certain molecules, in spite of having polar bonds, are found to be with a 0 dipole moment, and why certain molecules are having dipole moment, all that we are going to discuss in the 5th hour at 12:40 today. I request all the students to come to the class on time so that we can discuss a little more thing. And also one more announcement I have, at the end of the 40th minute, the Zoom meeting will get automatically disconnected. If it gets disconnected, you please re-enter through the same user ID and same meeting ID and the password I have already given you, and with the same IDs you enter into the meeting immediately. Now look here, when such a neutral molecule is subjected to electrical distortion. Electrical distortion means I am having two electrodes. One is positively charged and the other one is negatively charged. See, when the electricity is off, which means when these two plates do not carry any charges, the molecule is something like this. Actually, the center of the negative charge and the positive charge are one over the other. In order to have an understanding, I have simply written very close. Actually, they are one over the other. Therefore, they are electrically neutral. So, when you pass the electricity, when you make these two plates charged, so this is something like a capacitor arrangement. How many of you have seen a capacitor? Capacitor is nothing but two conductor plates kept closer with a dielectric between them. That is a condenser plate. And I want to explain the principle of the condenser plate. You may be knowing the ceiling fan. Sometimes the fan will rotate slowly. So when you ask the electrician to check it, he will say the condenser is failed, and he will replace the condenser with a new one, and then the fan will rotate at the normal speed. So you can take that cylinder like a condenser, and I want you to do all these things at home, and you have to have your own understanding. You just break a condenser and see what is inside. There will be a long sheet wound up, and that sheet will contain two conductors separated by an insulator. Two conductors are separated by an insulator. That is a capacitor arrangement, a condenser or a capacitor. The role of the condenser is to store electricity for a short time. It will store the electricity for a very short time. See, you will be having an analog radio. See, in the radio, you are winding a knob to change the frequency of the radio, and the different stations are caught up at different points. Actually, what is happening inside is there is a variable capacitor, a condenser. Normally, the capacity of the capacitor or the condenser, it depends upon the area of overlap of the conductors and also the distance of separation between the conductors. So actually, when you are tuning the radio, what happens is there is a semicircle shaped condenser. When you turn, it will go on overlapping like this, and also you are changing the capacitance of the variable capacitor by moving the discs. Therefore, at a particular point, you will get a particular capacitance. With that capacitance, that radio will be resonating with a particular radio station. This is how the radio station is changed when you rotate the tuning knob. So, capacitor means two conductors separated by an insulator. When they are charged, they are able to store the electricity for a short time. And the capacitance unit is a farad, 22 microfarad or 10 microfarad. You can get capacitors like this. So now, this is something like a capacitor arrangement. Look at this. There is a plate. Here is another plate. They are separated by a solution or some other dielectric substance. Now this is a neutral molecule. So when the electricities are connected, automatically what happens? The positive center of the molecule is shifted towards the negative plate due to electrostatic attraction. And also the negative center is getting attracted towards the positive plate due to electrostatic attraction. As a result of this, you are getting an electrical distortion in the molecule. There is an electrical distortion in the molecule. But this electrical distortion is temporary. Electrical distortion is temporary. And also it vanishes when the electric field is off. As long as the electric field is on, the distortion will sustain. Once the electric field is off, then the positive and negative will come closer and it will become a neutral molecule once again. That is why this type of polarization is called induced polarization. And also this type of a dipole is called induced dipole. Therefore, the polarization is an electric dipole is generated because of the electrical distortion caused by the applied electric field between the condenser plates, and the polarization is called an induced polarization, and the dipole is called an induced dipole. And also this induced polarization and induced dipole are temporary arrangements. They will vanish when the electric